So firstly, we are looking for the x being between 35 and 60. But we know that already the mean is 45 and standard deviation is 12.5. Sorry. So we can just substitute in our formula. We know the mean we know the standard deviation. So it becomes easy. The probability of having 35 minus the mean, which is just 45, divided by the standard deviation, which is given 12.5, minus our x that we're looking for, minus the mean, divided by the standard deviation. And the same goes here. The maximum point, which is 60, minus the mean, divided by the standard deviation. So here, we can compute that part, and you can compute that part. In our case, the first part would be equal to minus 8.80. In the middle, we have our z, because this thing corresponds to the same as z. And on the right, we have 1.20. And now it becomes easy, because if we have the normal distribution, and I'm going to draw here. If we imagine here is 1.2, and here is minus 0.8. It's not symmetrical, but still we can solve for that. We are searching for that area that is in the middle between those two numbers. That's somewhere here. And we can just take the probability of z being less than 1.2 minus the probability of z being less than minus this number that is here, 0.8. If we look in the tables for 1.2, you'll get the number 0.8849. And here, be careful, because here you cannot take the direct number from the table, but we have to get 1 minus the number. So the number in the table that corresponds to 0.8 should be 7.881. And in the end, the final result, our probability of the conditioned events should be just equal to 0.6730. Let me know if you understood. Did you get it? I'm going to clear everything and show you the whole solution. For B is the same way of calculating, but this time we have the number that is on the right. We have the area, and we have to calculate the number that is in the brackets. We do the same standardization, and if we have the number of the area that is 0.1, we have 0.1 here. And we can use the mean and the standard deviation to calculate the left part of our equation, which in the end would be b minus 45 divided by 12.5. If we imagine the normal distribution, and we're looking for the area that is above b, so b somewhere here, and the area above b would be 0.1. So it should be somewhere towards the right side. Now, if you imagine, we took the topic about quartiles. So we need to have to calculate z of 0.10. And why? Because here that area is 0.1. So if you have a look at the last row in the table, below 0.10, 10, you get this number, 1.28. And now it's just a matter of calculations to get the B, which would be equal to 61 in the end. Please let me know how it goes to you.
Can you maybe explain part B again?
Yes. If we are given that the area here is 1.1, 0.1, right? And we're given the area, but we need to know the number that is here below. So we just have to make the standardization the same way, but this time we are given the right hand side in order to find the left hand side. But here we needed to find the area that is the right hand side. So here we just plug in our mean, which is 45, and the standard deviation that is 12.5. And in the end, that here is just Z. That's Z. And Z, which means the area above certain B, should be 0.1. But we don't know that B, but we know the area. So we can basically take B to the left-hand side and calculate based on that area here.
Yes.
Did you get it?
Yeah.
Okay. I hope everyone else got the impression how to solve that type of exercise. I would say that part, I'm not sure if you have the time, but okay, someone is responding, great. Yes, okay, great, awesome. What kind of distribution does T have? Here it says that we select randomly, so that's important. 10 customers, which are denoted by X1, X2, and so on until X10. They're independent, which means that it doesn't matter what the first customer spent, it's not influenced on the second customer. For example, if I spend 10 euros, it doesn't mean that the second customer would spend 10 euros as well, or just more or less. I can spend 10, he can spend 1, the next one can spend 100, it doesn't matter. They're not dependent on each other. And T is the total sum of all those 10 customers that we selected. What kind of distribution does T have? What do you think? Okay, I would proceed. If T is our variable, it is normal distribution because we randomly select those 10 customers. So the first thing you have to write is the number of participants in our experiment, which is just 10. And later we have to take into account the variance, but we don't have the variance in that case. We only have the standard deviation. We can easily calculate it. It's just 12.5 to the power of 2. I'm not sure what's the chance of having such exercise to explain the distribution and the parameters in the exam, but I would say that from time to time, they gave it and maybe they say, almost when they ask for what kind of distribution, it's almost somewhere repeated in the exercise, because if you see, we have X here and it's the same normal distribution, but here we have T, it's almost the same. Just we have to take into account the parameters. Here we have 10 customers, which is reflected here, 10. And then the variance is the same as before. So I would suggest having a 10-minute break. I'm not sure if you want to have something to drink or to eat. Do you prefer having a break?
Yes, it's fine.
Okay. So let's say now it's 1:15, 1:25. We'll be back and continue with some more exercises. How are you guys? Do you feel better? Okay,
Yes, thank you.
great. We just have a few more exercises, so we are almost to the end. Yeah, ready to go. Great. So the next exercise, and all of those exercises that we're covering right now, which are at the end of the crash course, are from the real exams. So it's a nice practice before it. So we have an Albert Heijn store, and 45 customers are randomly selected from a larger group that can visit the supermarket during a certain period. And we are interested in those that pay with a bank card. So I will leave you a few seconds to think about the exercise and what we need in order to calculate the expectation and then the variance. For the moment, just think about point A. Later, we're going to do together point B. And remember to look at the information that is here. Don't look at the table here because it's not useful for A and B. Did you calculate the expectation and the variance? And if you have questions, not questions, but the results, some numbers, Feel free to share.
Is the expectation 27?
Yes, that's right.
Okay. And the variance 10.8.
That's right. Awesome. We just have to remind ourselves that it says we are taking only 45 customers from the whole population. And we're given the probability of having a success, which is paying by card, which is 0.6. And then the number of participants that we have in our experiment, which is 45. And if we know that it's a binomial distribution, we easily can calculate because this is n times p for the expectation. And then we have for the variance n times p times the probability of having a failure, which is 1 minus p. That is A. If we have to look at B, we need to determine what is the probability of having exactly 25 of those customers paid by card. We already did a similar exercise. We know that we can choose from all those 45 customers, we choose only 25 to pay by card. So we have to choose from 45, only 25. And multiply by the probability of having a success, which is 0.6 to the power of, can you help me? What would be the power here? (0.6) is the probability of having a success. So the power should be the number of success we have in our experiment, which is 25 because that's what it said in the exercise. To the power of 25, but also we have to write the probability of having a failure, which is 0.4, to the power of number of failures, which in our case, if we have 25 successes, we would have 20 failures because the total number is 45. In the end, number should be 0.0991. Now we have to look at the table and to determine the probability of having x being more than 26 and later another probability. But let's start at x being more than 29. What would be the number of having such a probability? You just have to sum up 3 numbers.
Yes, sum up the last 3 numbers.
Yes, okay. And in the end, that should be equal to 0. I'm sorry, that's not right. Why do you want to sum up all those 3 numbers?
because it was 29 and higher.
Yes, that's true. But do you notice that the number is increasing? So in the end, it should be equal to 1. That's
Yeah.
the cumulative. So for example, 29 here, it doesn't include only 29, but includes 27, 28, 26, and so on. So here, we have to take 1, and you have to minus the number that is right before 29. That's everything below 29. Because here, we don't include anything that is above. It will become 1 minus 0.6782. 28, sorry. And that should be equal to 0.3272. If I'm not wrong, I'm just calculating it. Because if you calculate all those 3 numbers, you will get a huge number somewhere around 2 or 3. But that's not possible to have a number with 2 or 3 as a probability. It's always up to 1. And the next probability, we have to calculate x being between 26 and between 30, including 30. What can we do here? Does somebody have any suggestion? We just have to take a look at where the 30 goes. Here we have the probability of having 30 customers is 0.85, which includes all customers up to 30. It could be 25, it could be 30, it could be 28, doesn't matter. So we have to take that probability, which is 0.857, minus, we're interested between 26, so in here, up to including 30. So we have to have minus the probability of having 26 customers, which is exactly 0.4357, which is right here. And in the end, the answer should be 0.22. 13. Best without 13. 32. Oh no, with 13. Yes, it doesn't matter. Yeah, it's always the same. Do you have any questions for that exercise? I will assume no. So I will show you the nicely written solution. And if you're ready with writing down everything, let's have a new one, which is again with probabilities and tables. We have to consider the whole populations of Dutch households, and we know that 37.7% of them are just single person. Suppose, so we have 50, we're taking only 50 households, which are randomly selected from the whole population. And why is the number of single person households among our sample of 15? So we have to determine what would be the distribution that is presented in the parameters for the distribution? We had a similar question just a few slides back. When we're taking a random object from the whole population, it's always binomial distribution. So we have our event, which is y, denoted by the binomial distribution. And here we have to take n and p. Firstly, and how many participants do we have in our experiment?
$50.
Yes, that's right. And then the probability?
7.7.
Yes, exactly. Thank you. And that's our binomial distribution for point A. That's everything we need to know and to write down. The next question asks us to determine the probability of having y exactly as 17. We don't have continuous, so it's not 0. What we need to know, we need to have 17 people from our sample, that is 50. So from 50 people, we have to choose only 17. That need to be single person household. Then we need to know the probability of having a household of a single person, which is 0.39 to the power of our number of successes, which is 17, because we're searching for 17 people. Then we need to have the probability of having a failure, so not a single person household, which is 1 minus the probability of success, which is 37, to the power of the number of failures, which is 50 minus 17, which is, if I'm not wrong, 33. And if you calculate the whole number of this one, it should be in the end 0.102. We did similar calculations than before. And now we have to use the table to determine the probability of having y exactly between 20 and 24. And here we have the same case. Here it's a cumulative distribution. So it's going towards 1. So what would be your suggestion? We're interested in the numbers between 20 up to including and 24, but not including 24. So in that interval.
Then take the number of 23 and subtract the number of 90.
Yes, exactly. So we have 0.9114, which corresponds to having 23 participants of single households minus the number that corresponds to 90 participants, which is here, 0.5796. And in the end, the result should be 0.33. I see someone in the chat. Yes, exactly, yeah. But no, sorry, we have to take 23. And why? Because here we don't have a sign for equal. It has to be necessarily below 24. It can't be 24. If here we have that sign, equal or below 24, you would be correct. But we don't have it. Do you have any questions? No, okay. So I'm going to continue to the next exercise. That's the solution. And here, take in mind that's relative frequency. So it means that each number that is here corresponds only to the value that is above. So it's not cumulative. So I'm going to give you 5 minutes. So let's start from A. Do you think that X is discrete or continuous? That's an easy one. Discrete, that's right. Because here it says it's number of magazine and newspaper. You cannot have 1.5 magazine or newspaper. So the next question is sketch the bar chart of the relative frequency distribution of X. And you have to indicate if it's symmetric, skewed, or etc. So we have the relative frequencies already, so it would be easy. Draw the graph. And we start with 0. We have 1 up to 4. For 0, we know the relative frequency is 0.22, 28. So let's imagine that's somewhere here. So for 0, that's our bar. It says bar chart somewhere. Yeah, bar chart. So bar chart, it looks like, oops, it looks like this. We have different bars. So it has to resemble that part. Nextly, for 1, we have, it says 0.55. So let's imagine that somewhere here. and 0 goes up to 0.55. So now we go to 2. 2 corresponds to 0.08, which is really small number somewhere here. Then we have for 3 even smaller, 0.05, which is even like this. And then for 4, almost the same as 3, like this. And all of those are bars. That's why it's called bar chart. So B is ready. Oh, we have to indicate if it's symmetric. So we can know for sure that that's not symmetric because we have just one high bar and then they're low. So it's skewed to the right because in the right side, the bars are decreased step by step. So it's skewed to the right. We have to draw the graph of the cumulative distribution. So now for C, we have to sum up the numbers. For example, here we have 0, 1, 2, 3, 4. Firstly, for 0, we would have, before 0, we have just zeros. Up until 1, we would have 0.28, which means that everything between 0 and 1 is at that point. Later, if we go to 2, we have to add, from this number, we have to add this number. So it became 0.28 plus 0.55 should be equal to, let me draw it there. $83, if I'm not wrong. Correct me if I'm wrong. From 1 to 0, it goes like this. That's cumulative, so it means it's gradually increasing. So in the end, it should be somewhere in around 1 and going forward. Later, between 2 and 3, we have plus 0.08. So it's somewhere here, 0.91. So it's somewhere here. Later, we are going to 3 and we add 0.05, which is 0.96, which is somewhere here. And the final stage is to add 0.04, which is everything above 4, because it's cumulative. So that's where 1 lies. I hope those graphs are easy to understand and to replicate. Nextly, we have to determine